Okay guys, so we're back. I don't really know exactly why my microphone isn't working properly, but I do apologize. Either way, hopefully you can all hear me and we can get through this equally. So it says this is page 5 of our review, and we have solve using the quadratic formula. Remember, the quadratic formula is x equals the opposite of b plus or minus the square root of b squared minus 4ac. All of that is over 2a. Now remember, we're looking for the zeros. So this part over here must be 0. I need to move that 20. And honestly, that's the biggest mistake people make, is they forget to move that 20 when they're doing this problem. So we're going to have 2x squared plus 3x. We're going to subtract 20 from both sides, so that way we can move it. Minus 20 equals 0. So that gives me an a of 2, a b of 3, and a c of negative 20. So we're going to take these and plug them back into this formula here. So x equals the opposite of b, which is negative, and then 3, plus or minus the square root of 3 squared minus 4 times 2 times negative 20. All of that over 2 times 2. And from here, we just use order of operations. Now, we won't be able to use a calculator. There's no calculator icon here. So x equals negative 3 plus or minus 9. Negative 4 times negative 20 is positive 160 times 2, positive 80 times 2 is positive 160. All of that over 4. And it's going to proceed to be negative 3 plus or minus the square root of 169 over 4, negative 3 plus or minus 13, because the square root of 169 is 13. And then we're going to go ahead and do that simple math there. Negative 3 plus 3 is 10 over 4. Negative 3 minus 13 is negative 16 over 4. And those two things can be simplified. 10 over 4 is going to be 5 over 2. And negative 16 over 4 is going to be negative 4. So our answers are negative 4 and 5 over 2. Now, number 2 says you solve the quadratic equation using a method other than quadratic formula. A lot of you guys have been going and doing quadratic formula every single time. This one is easy to solve by factoring, because we can factor this into 2 parts. So one thing we could do, we could either divide everything by 2, and then we'd have 4, or sorry, not by 2, by 4. 4x squared minus 4, and that still allows me to do this math here, okay? This is still a perfect squares, difference of squares. So we have 4x plus 2, x minus 2. Remember, when we have the difference of squares, okay, when we have the difference of squares, we just take the square root of the first and the square root of the second and make them conjugates of each other. Remember, they're conjugates. So what I'm going to do here is I'm going to go ahead and set each factor equal to 0. X plus 2 equals 0, and x minus 2 equals 0. So I'm going to subtract 2 from each side, and x equals 2. And here we're going to add 2 to each side, and minus 2 here equals 2, and x equals positive or negative 2. My notation is being weird. All right. So that's pretty simple. Okay, so the next ones we're allowed to use the calculator for. It says if the length of a rectangle increased by 6 inches, the area becomes 135 square inches. Determine the original length of the rectangle. So all we're doing is solving for x. So we don't need this square anymore, okay? We care about this one. The area equals 135 square centimeters, or inches. So we're going to set it up for area. Remember, area is equal to length times width. And so there we're going to have our area equals x times x plus 6. And that gives me area equals x squared plus 6x. And our area is 135, so we're going to plug that in there. 135 equals x squared plus 6x. Now we could do this one of two ways. Or actually, we could use any method we want. We could do it by graphing in our calculator, since we are allowed to use a calculator here. So minus 135, minus 135. And that's going to give me x squared plus 6x minus 135 equals 0. So let's go ahead and we'll do this one in the calculator. We'll do it using graphing. So all we're going to do is switch over to our calculator, and we're just going to type in our equation, x squared plus 6x minus 135. Okay. Now, this one will have a root on the outside, but look, we only really care about this root that's on the positive direction. Remember, we only care about the positive one because we're talking about length. But let's go ahead and zoom out just so we can see them. There we go. We have one over here and one over here. We only care about this one. So the way we're going to find out what that number is we're going to go Menu, Analyze, 0. And we'll put the lower bound to the left, upper bound to the right, and it gives me 9, 0. So x equals 9, because we only care about the positive ones. Right? And remember, anytime your question is in words, your answer should be words. So the original length is 9 inches. And that's all there is to that. Pretty simple. All right, number 2. Again, we can use a calculator here. The product of two consecutive negative even integers is 120. So remember, our first integer is going to be x, because it says x is the smaller. And our second will be x plus 2, because we're looking at only the even. So we want to go to not the next number, but the next number. We're going to multiply those two together. X times x plus 2 equals 120. We get x squared plus 2x equals 120. And we can go ahead and use this one. We can just go ahead and complete the square. We have here 2. B over 2 would be 1 squared. So we're just going to add 1 to both sides. So we're going to complete the square. X squared plus 2x plus 1 equals 121. And we write that x plus 1 squared equals 121. Take the square root of both sides, and then we end up with x plus 1 equals plus or minus 11. Subtract 1, and we are going to end up with x is equal to negative 12 and positive 10. But we don't care at all about this 10 right now. We only care about that negative 12. So if x equals negative 12, x plus 2 equals negative 10. And so the integers are negative 12 and negative 10.